Name the elements whose isotopes are used in nuclear reactors. And here we see is uranium. Uranium is used in nuclear reactors. And next is treatment of cancer. And for treatment of cancer, the isotope of cobalt is used for treatment of cancer. An atom has 5 electrons in its M shell. What is its atomic number? So you have the K, L and M shell. And they said it's got 5 electrons in the M shell. So I put 5 here, which means the other shells are already filled. There's 8 and there must have been 2. So when you add up, the number of protons now is 15. So electrons will also be 15. Give 1 point of similarity and 1 point of difference between the isotopes. So we have here C14 and 6, C12 and 6. And if you notice here, this is 6 and this is 6. So the atomic numbers are same. Similar, that is a similarity. Atomic number is same. And that is 6. If atomic number is same, the chemical properties will be same. And if chemical properties are same, definitely configuration, electronic configuration is also same. Now what is different? You see here this is 14 and this is 12, and that is mass number. So mass numbers are different. One is 14 and one is 12. Now in the first sample we have carbon 14 and 6. That means protons is 6 and protons plus neutrons is 14 because mass is 14. So the neutrons will be 6 neutrons equal to 14. So here neutrons will be 8 in this case. Now in the second case we have again carbon 12 and 6. So protons 6 and 12 is a mass number, means protons plus neutrons is 12. So 6 plus neutrons is 12, neutrons is 6. So this is the basic difference between the two. Here the neutrons are 8, here the neutrons are 6. So the mass numbers are different. Write the atomic number of an element which has mass number 23. So let's write down mass number equal to 23 and neutrons 12. So neutrons equal to 12. If mass is 23, mass we know are protons plus neutrons, and this is 23. So protons is P, the neutrons we know is given as 12 here. So we write 12. So this is 23. So protons will be 23 minus 12 and protons will be 11. So they asked us find the atomic number. Now atomic number is number of protons. Which is equal to 11. So atomic number is 11. Identify the isotopes. So these are the elements. We have got to identify the isotopes. So the numbers in the blue are the mass numbers, and the numbers in the yellow lower are the atomic numbers. Now isotopes are elements that have same atomic number, which have the same atomic number. Now if you look up at this, you have this 17 and C also has the same atomic number 17. So A and C are isotopes because they have the same atomic number. Atoms with same atomic number are called isotopes. An atom of an element X is written as, so we have X written as 9 and 4. What does 9 indicate? Now, as we have seen earlier, 9 is the mass number. And 9 equal to mass is protons plus neutrons. Now, here we see that 4 is the atomic number. This is atomic number. And atomic number is number of protons. So, number of protons is 4. So, here I put 4 number of protons. So, 9 equal to, so 9 is minus 4. So, n equal to 4, 5. So, you have neutrons equal to 5. Name the 3 subatomic particles in an atom. So, we have 3 subatomic particles and they are the electrons, negatively charged, protons, positively charged, neutrons that are neutral. If the K and L shells of an atom are full, what would be the total number of electrons? So, we have K and L shells and they are completely full. There will be 2 in the K, 8 in the L. So, when you add up now, you will get 2 plus 8, there will be 10 electrons. If there are 10 electrons, means there are 10 protons. What can you comment on the reactivity of the element? If you look up at this element, the valence electron, the outermost electrons are 8. So, the outer shell is satisfied or is stable, because it has got the octet state. This is called the octet state, when the outermost, there are 8 electrons in the outermost shell. So, this atom will be unreactive. Why unreactive? It does not have to gain, lose or share electrons, since the outermost shell is got 8 electrons. Why the chemical properties of isotopes are the same? The chemical properties. First point is isotopes have same atomic number and because they have the same atomic number, they have same electronic configuration. And since they have same electronic configuration, they have same number of valence electrons. The outermost electrons are same, and if the valence electrons are same, they'll have same chemical properties. And that's the reason why the isobars have different properties. Isobars, they have different chemical properties. And the reason, because they have different atomic numbers, they have different configuration, electronic configuration is different, and different valence electrons. If the arrangement of atoms is different, the valence electrons also will be different. Which has more electrons, sodium atom or sodium ion? So, let us examine the sodium atom. The number of protons are 11, because the atomic number is 11. Electrons are also 11. And the configuration we know is 281, unstable. So what does it do? It loses one electron. And when it loses one electron, it becomes a sodium ion. Now sodium ion, the protons is the same because it has not lost any protons. Electron it has lost. So earlier it was 11. Now the protons will become 10 because one is lost. And the configuration of sodium ion will be 2, 8. And the question is, who has more number of electrons? Now let's compare. Here there are 11 electrons. Here there are 10 electrons. So who's got more number of electrons? It is a sodium atom, has 11 electrons. While the sodium ion has 10 electrons. So sodium atom has more number of electrons. What are isobars? They are atoms of different elements that have same mass number but different atomic number. And the example of isobars is argon and calcium. Both have same atomic number, so it is 40 and 40. Mass numbers are different. This is 18 and this is 20. So example is argon and calcium. Give two differences between isobars and isotopes. So for isobars, they have same mass number. Here isotopes have different mass numbers. Then when it comes to atomic numbers, isobars have different atomic numbers. Here these have same atomic number. When it comes to chemical properties, since atomic number is different, they'll have different chemical properties. Here same chemical properties. Example of isobars we've just seen here: argon, calcium, same atomic number, the same mass number, atomic number is different. And when it comes to isotopes, like isotopes of carbon, they both have same atomic number, mass numbers are different. The electron configuration of an element X is 282. Find the number of electrons present in the element. So configuration is 282. So you have KLM shell 282. So when you add up this, you get 12. So 12 are the protons, are the electrons, because this is distribution of electrons. It has 12 electrons. Next is, what is its atomic number? Now atomic number is number of protons equal to number of protons, and we know number of protons equal to number of electrons. The electrons are 12, so the protons also will be 12. So atomic number is 12. Next, is it a metal or a non-metal? Now that depends on the valence electrons. Now valence electrons are 2. So it becomes a metal. Let me explain this part, difference between metals and non-metals. It all depends on valence electrons. For metals, the valence electrons are either 1, 2 or 3, and for non-metals, those who have valence electrons 4, 5, 6, 7, 8 are said to be non-metal. So you need to remember this. Find out the valency of K. So we saw the configuration was 2, 8, 2. So to get stability, it will do what? It will lose 2 electrons. And because it loses 2 electrons, the valency equal to 2. So when it loses 2 electrons, it will form 2, 8. Here it has lost this electrons. So the valency will be 2. Which of them, sodium or helium, has completely filled K and L shells? Give reason. For this we must know atomic number. Sodium atomic number equal to 11. So configuration is 281, and when it comes to helium, atomic number of helium is 2. So configuration is just 2 in the K shell. And if you were to compare their stability, you will see that helium is in the octet state. The K shell is filled. K is the outer shell, and this outer shell is completely filled. So helium is stable. But sodium, the outer shell is, you see here, KLM. Outer shell is the M shell, and it is not completely filled. M is the outer shell. Check up and see how many electrons M has got. M has got just 1 electron, so not filled. So sodium is reactive, it is not stable. Helium will be non-reactive because it is stable. An atom has electronic configuration 287. What is its atomic number? So configuration means distribution of atoms, 287. So atomic number you add them up, so you get 2 plus 8 plus 7, that is 17 protons. In fact 17 electrons here, because this is distribution of electrons, right? So you have 17 electrons, which means 17 protons also. Electrons equal to protons. So atomic number is protons, which is equal to 17. The next is, to which of the following would it be chemically similar? So let's write, for example, nitrogen, 7. So configuration of nitrogen is 2, 5, 2 plus 5, 7. Then we'll take up chlorine, is given here, 17. So configuration 17, so 2, 8, 7. And then we have phosphorus, 15. So configuration of this, 2, 8, 5. And of the compound that we know, the compound is 287. This is a compound which is given to us. Now look at the valence electrons. It has got 7 valence electrons. Which others got 7 valence electrons? Here, chlorine has got. So it will have properties just like chlorine. So chlorine also has 7 valence electrons. So the chemical properties of this element will be similar to that of chlorine, because both have same number of valence electrons. In fact, it is chlorine itself. 287 is chlorine. The number of protons, electrons and neutrons are given below. Give the electronic distribution of B. Now, so this is B. We have to write its electronic distribution. So if you see, B has got 16. B has 16 electrons. So configuration will be 2, 8, 6. Now next they say, this was question 1. Now we'll go to question 2. Write the valency of A. So here is A. To know the valency of A, we must know how many electrons it has got. So A has 9 electrons. 9 electrons means it will be 2, 8, that is 10, right? So it will be 2, 7. That is 9. So 1 electron is missing here. The outer, here you have the K and the L. L shell has got only 7 electrons. So it will accept 1. So valency equal to 1. It will accept 1 and then become 2 and 8. So valency is 1. For the third, what is the atomic number of B? So here is B. Atomic number is number of protons. So for B, number of protons equal to 16. So atomic number 16. What is mass number of D? So we just put D here. So we have mass number of D, and you know mass is protons plus neutrons. So you have protons plus neutrons, that is 17 plus 22, which is now 39. Mass number is 39.